everyone. Welcome to this video on Introduction to Quantum Computing. This will be among the series of videos that I will release on my YouTube channel, What the Heck. So this is the introduction part of the quantum computing series. How could you understand the word quantum? One of the ways to get a better explanation of this is to understand the term quantization. Quantization means the representation of physical attributes of an object in terms of discrete values rather than continuous values. For example, as you can see, the girl climbing the stairs can be in a superimposed position of both at the lower ladder or at the upper ladder, which is represented by 0 and 1. However, if you see the person sliding up and down can only be in a position of either 0 or 1. This superimposition gives the value of quantum its unique attribution, which is useful for further purposes. The best way to understand superposition is to look at the thought experiment which was conducted way back in 1950s or around 60s by Schrödinger, and it is called Schrödinger's cat. The idea was to build the relationship between different uncorrelated attributes in a superimposed position. The experiment was conducted by putting a box having a radioactive material inside it, a bottle of poison, and a cat inside it. That can be in a dead or alive state. So when you look at it, you will see cat either as dead or alive, but not both dead and alive at the same time. Idea was that if the radioactive material decays, it will lead out to the radiations, which will break the poison glass, and the explosion of the poison in the box will lead the cat to death. Therefore, by looking at the state of cat being dead or alive, you will be able to make a superimposed judgment whether the radioactive material has decayed or not. Some like AI has also gone through revolution phases. The first and the foremost quantum revolution happens in terms of the particle wave duality in electrons, which was studied in order to understand the semiconductor physics, which has led to the development of chips as we know it now, which is getting used in our everyday life. Further on, the particle wave duality in photons was studied to understand the photoelectric effect, which we use in solar panels, the renewable energy source that we use as part of sustainability drive. Second quantum revolution was about using the information theory, the technologies, and the concepts of quantum mechanics to basically create unnatural states for our own purposes. For example, processing the values of a complex problem, which we cannot do in terms of only zeros and ones. This has led to a phenomena which is called as quantum supremacy, and it is defined as the concept, or rather an ability, of devices to solve problems that our classical computers, which are based on zeros and ones or bits, will not be able to solve. Google, for instance, in 2019 claimed that something on a quantum computer can be solved in 200 seconds, which will otherwise probably will take 10,000 years on classical computing. And University of Science and Technology in China also made a claim in 2020 about similar nature. As the revolution of quantum increased, so does the interest, and the expense on this technology has gained a lot of traction. Now, this is a figure from 2020. As we stand in 2025 today, it has drastically changed. But if you look at it right across the globe, countries, in terms of their academics, in terms of their military institution, and through combination of both, are investing very heavily on quantum computing. They have created dedicated funds to support the development and further enhancement of this technology. Applications of quantum are manifold. It can be used in material simulation to finding new materials, logistics and planning, financial market for developing new trading algorithms, decision-making systems, real-time services like sensing, in cryptography or in cyber security to help detect financial crimes, and also in terms of sustainability of having, for example, better quality solar cells which generate more electricity consuming less sunlight, or in case of there are no sunlight. The era of quantum computers is being on a progressive path. So from 1980s, when Feynman has given his lecture on quantum computing, to up until 1994, when the Shor's algorithm has been discovered by a Shor, there is a bit of infancy in and around that time. Even at that moment, there are less than 50 logical qubits that have been existing, and therefore it is imperative that to gain the actual value out of the algorithms, this count of qubits and the actual quantum computer grows, which is further followed up until 2019, when the NISQ era quantum computers, as depicted by Google, has came into picture, and they have done a great job in making noise intermediate scale quantums, which are still based on physical qubits but noisy qubits, so the stability will still be at stake, but the progress is far reaching. There is a prediction and expectation that by 2035, the fault tolerant or a fully capable quantum computer will be available, which will be able to use the capabilities of the algorithms which has already been discussed, which has already been discovered decades ago. For example, a thousand logical qubits, probably more than 1 million physical qubits, with the full connectivity of quantum computers towards each other, led to improved processing of information and solving of the problems which up until now cannot be solved by classical computers in a feasible duration of time. Up until then, what does it mean to be aligned with this technology? It is progressing, but it still doesn't have a great commercial traction as some of the other competing technologies like artificial intelligence and chip making have. We have to understand that for developing quantum-based applications, we will have to go through the phase of understanding what quantum is, to experiment with it, to make sure that we really understand that the algorithm which works in theory also works in practice, and then delivered the value, so to make sure that the return on investment is properly attributed. The approach for this would have been to combine different sciences, different areas, and work in conjunction with each other. So, for instance, the science of physics, applied mathematics, and a computer science can be in junction with each other to use the capability of quantum computing. Therefore, it is important to understand quantum computing that you have essentials of mathematics clear to you, fundamental quantum circuits, the fundamentals about the algorithms is clear to you, the actual application where you're gonna use this, whether in terms of optimization, deep learning, simulations, and whatnot. And also to judge the impact and the practicality of that application in terms of applying it to quantum cryptography, making sure that there is a noise reduction in the circuits so that you get the benefits out of it. There are a few more topics that will be added along the way to make it better understood of what it is to use quantum computing. I'll stop here. I encourage you to be aligned and develop this curiosity to learn about quantum computing because the area is very wide and being is been expanding at a very quick rate. So you have quantum technologies in the tech domain, you have quantum sensing, you have quantum communication, quantum key distribution, and you have the merger of quantum tech with the classical tech which we are using today, the way, for example, we are using a laptop. So thank you very much and keep learning.